Yeah, I did. Can you see it?
Not yet, Sophia. We can't see.
Oh, it's a bit strange. Let me try again because it allowed me to share. But yeah, I did share screen. Oh yeah, I didn't do one thing, which actually is clicking on the share. It would have helped a lot.
Yes, we can see your screen.
Yeah, well, yeah, okay, so no problem.
So we'll wait for about 5 minutes, Sophia, and then
Yeah,
we'll start again.
we can start. It's in 10 minutes. I
Yeah,
have it.
sure.
All right.
Thank you.
Okay.
Dear all, welcome back. We'll start with our next keynote speaker, and it is with great enthusiasm that I welcome Professor Sophia Ananiadou, who's joining us online. Sophia Ananiadou is a professor in the Department of Computer Science, University of Manchester, UK. She's also the Director of National Centre for Text Mining, the Deputy Director of Institute of Data Science and Artificial Intelligence, a distinguished research fellow at the Artificial Intelligence Research Center, AIST, Japan, and a senior researcher at the Archimedes Research Center, Greece. She was an Alan Turing Institute Fellow from 2018 to 2023. Currently, she is a member of the European Laboratory for Learning and Intelligent Systems, which is ELIS. Her research contributions in natural language processing include tasks such as information extraction, summarization, simplification, emotion detection, and misinformation analysis. In today's keynote talk, Professor Ananiadou will speak on emotion detection and LLMs, transforming mental health and countering misinformation on social media, where she'll focus on specific aspects of affective classification for analyzing mental health through natural language processing techniques. She will also discuss the importance of affective factors in detecting misinformation and conspiracy theories. Thank you, Professor Ananiadou, for gracing the event, and over to you.
Thank you very much for the invitation, and I apologize I'm not in person in Liverpool. After all, it's quite so close to Manchester, so again, many commitments. I have to apologize in advance because I've changed slightly my talk to make it a bit more coherent. So I will not talk about mental health, but I will talk about emotion detection. But I will mention public health, how this work has affected some work we have done on public health, misinformation, and conspiracy theories. I don't need to say that a sentiment analysis and emotion detection play a very important role in natural language processing and benefit many downstream tasks, like the ones that I'm going to discuss. So emotion detection is really pervasive in many tasks, and we all more or less know about this. First is about author profiling, when we have fine-grained information can help us to understand communications or contrasting, for instance, between groups of users, those who are expressing the same types of emotions or not. And this is, again, very important for misinformation that I'm going to discuss later on. So we also can infer by this contrasting between different groups, users' attributes such as age or gender or education, ethnicity, etc. It's also very important for customer experience and understanding customer experience, how we can boost their motivation or allow them supporting users to share experiences about products and services, and how they can interact with different types of feedback. An important part, which is more or less I will discuss today, is how emotion detection can help us to track online users' emotions. And this has been extremely important for quite recently about the COVID, and I'll discuss about that, how we can flag, for instance, emotions which are also threatening or abusive or risky, and very much tackles misinformation. And last, also health. We monitor health, different emotional changes, well-being. Emotion detection has been used a lot for mental health, which today I decided not to include in my talk, but also how to prevent or detect potential suicidal behaviors or thoughts. So, and also this type of work, where I mentioned here, emotional contagion. This is very important for mental health and for inciting risky behavior. So my talk is going to be about some methods that mostly my PhD students have developed on emotion detection, and how this has affected how we understood public opinion and public health during the COVID pandemic in the UK. And then I'll talk about how emotion detection is important for misinformation, the emotional large language models we have developed, and how these have formed the basis of the conspiracy detection we have done by developing a conspiracy emotion LLM. So this is the talk is all about emotions and how what we can do by detecting emotions. I don't need to say about the relevance of social media, about Twitter, Facebook, etc., how people are sharing and browsing on the web clearly increases the risks that we have of also detecting having fake news and rumors. But also what is quite sort of scary is the really lack of effective regulatory measures. And this type of work of analysis very often can affect emotions, can affect people's daily lives or also alter their emotions and behaviors, and lead them to very often to trust incorrect information. An example here that we have about the internet and some of those types of rumors we have mined in the work that I'm going to present. It's about myths about COVID, that if you just, for instance, exposing yourself to high temperature prevents COVID-19, or regular rinsing your nose could with saline prevents COVID-19, etc. I don't need to read all that. We all have heard them. And then we have sentiments, positive and negatives, and different types of emotions, which are all discussed from and emojis from sadness, etc. So my whole talk is going to be about the close relationship that we have between emotions, and a lot about misinformation. And there are, of course, other studies we have which have used emotion or sentiment as features for misinformation, and I will discuss them a bit further down. So before that, I will make a small detour about emotion detection. And this is the work of my ex-PhD student, Al-Huzali, on SpanEmo. So in a nutshell, I'm not going to discuss the methods, but obviously emotion is a complex phenomenon. It is subjective, and it's also context sensitive. So we're very much interested in the emotion correlation, so the multi-label emotion classification, which also aligns with the different well-known psychological theories of emotions. I'll mention Plutchik's, but there are other theories of psychological theories of emotions. So emotion correlations are really important because they can model also between different labels, but as well as between instances. So in here we have a very well sentence. They started off great. The mocha machine wasn't working. So we have like great, and then we have sadness or anger or frustration. So we have a mix of positive and negative emotions. So what it's important to do is to enable the emotion recognition models to learn these associations, specific associations between emotions, but taking into account label information. So we're really benefiting from having this multiple coexisting emotions, as we see in the sentence, in a multi-label emotion data set. So this is SpanEmo, and I'm not going to describe it because it's just an example of casting multi-label emotion classification as a span prediction problem. And here we have different types of analysis. So first of all, it's associated with single label, the task single label classifications. We assign a single emotion, or in this case, a multi-label emotion classification. So we can choose one or more emotion for each input sentence. And then also the EDL is more about emotion distribution learning. So you can extend the multi-label emotion classification by learning the intensity of values of its input instance. I'll come back to the intensity of emotion when we were discussing misinformation and conspiracy theories. So we have this type of associations of learning, word emotion associations and the correlation. So you have the different topics, you have emotions between anger associated with words, and then the correlations. So if you're interested in SpanEmo, you can just also read the paper, slightly old. So why this has been important is because they've been very useful for detecting. Here you have the word level, at word level, you have an emotion like anger, and then you see words associated with the anger. So these words have been discovered by the SpanEmo, and they're quite indicative of the corresponding emotion. This actually also helps us to show that you can discover meaningful associations between emotion classes and words automatically, which obviously can be quite useful for feature extraction and learning. So we also can see that SpanEmo also demonstrated that you can learn diverse types of words as well as shareable words across emotions. So, for example, I think I have them somewhere here. The words like wrath and smashed are associated with anger and disgust. In short, we can by taking into account emotion correlations is quite important for the type of multi-label emotion classification that we're discussing, also to discover different types of ambiguities. Again, that is from the SpanEmo paper. We can see the two emotion correlations which have been obtained as obtained from the ground truth, the A diagram, and then the prediction that we have done with SpanEmo. As we can see, more or less A and B is quite close, quite similar. So we see that the method has been able to capture emotion correlations close to the ground truth. And also we see as well that negative emotions are positively correlated with each other. So basically, negative go with negative, and also negatively correlated with positive emotions. So this is actually a very brief introduction. I cannot go into the details because there's been more work on that, is to mention that emotion recognition can be modeled better by taking into account emotion-specific associations. So the correlations between words and emotions. And this actually allows us to address ambiguity, especially in a sentence when you have positive and negative emotions. And also SpanEmo has been used in different languages, has been used for Arabic, English, and Spanish, and has been applied to several corpora without requiring any modification. So the reason I said all that is because I wanted to say how we used it in capturing an example of mining public emotions and health. And this is, again, slightly old work of 22, but we used it to understand public emotions during COVID-19, the pandemic. And we did a comparative geolocation analysis on Twitter, about 500,000 tweets between 2021. The tools we used was Sentinet, I think 6 for sentiment analysis, negative, neutral, positive, SpanEmo, that's why I had to talk about SpanEmo before, for emotional recognition, and also a kind of combined topic modeling. So we used the topic modeling to geospatially analyze the sentiment, the emotion, and the topics of tweets in the UK. So this is really an example of how we use SpanEmo. You can see the number of tweets per city in UK. And the bold represents the top 9 cities. And we have here Manchester, and when we have Liverpool, so interesting stuff. And then we see as well here the different emotion labels. We also use emojis, so which are very well known in these tweets of COVID. For just very quickly on the content-based, the topic modeling, you can see the it's been misplaced a bit. Tweets with topics like sick, death, health, COVID, isolation. And here we see the emotion detection with fear, the same words associated the topics with the emotions, fear, sad, anger, and anticipation. We conducted, again, several types of analysis, which are focused on the sentiment, on the emotion, and the topic modeling of COVID online data sets. So the reason I'm mentioning this is because we analyzed the emotion words and the topic words associations, which actually show us the relevance, the relationship between words and their respective emotion label and the topic. So you see here, different red heart or thumbs up and thinking face and hands up and all those different topics and with the emojis as well and words. So within it was quite important for us to also look at the location, the geolocation, to see if people from different cities in the UK, they have different types of feelings and emotions about the pandemic. We also did other work, which I won't mention, like, for instance, the time-based features, but I'll skip that. So we see a kind of, how, the different emojis that people were using and the different types of associations between words and topics during COVID. So here we see the words, which are, again, indicative of the corresponding emotion. So, for instance, the words like death and spread are highly associated with the emotion class fear, when we have words like vaccine and support are highly associated with the emotion class anticipation. So this is a bit more of an example of the distribution of sentiments. Some of them were a bit more strongly positive of sentiments, and some very negative. So, for instance, Leeds has more negative feelings about the sentiments during COVID, and Leicester a bit less. So we looked at this distribution of sentiments again against the sample of UK cities. And also the emotion expressions. For instance, things like anger, it's prominent, but also we have sadness or disgust and, optimism. So there is a kind of an equal, but in some cities, there's a bit stronger types of negative emotions. To finish that, the whole idea was to do an analysis of combine the sentiments, and we used SpanEmo emotions and topics to find the public concerns during the pandemic. Clearly, this type of work can be done in any type of analysis where people are discussing events, or it doesn't have to be health. But it's about social media analysis where topics and geolocation and emotions play a very important role in understanding the trends and the feelings and feelings of people. But also it tells us a lot about the complexity, because we just mentioned emojis here, but in this case, one can imagine how multimodal images or even videos could be used and analyzed to understand the diversity of people's perceptions towards any kind of event, such as the COVID pandemic. So now it takes me to the next part of my talk, which is about emotions and how emotion detection evokes, how it's related and how it can affect the misinformation detection. So, of course, misinformation evokes lots of strong emotional reactions. As we know, there could be, as we call them, high arousal emotions, anger, anxiety, surprise, fear. And one of the key reasons that misinformation is spread is because it evokes this type of emotive and affective, feelings. And also rumors or fake news, which are associated as a type of misinformation, typically they have their own behavior. So is to what extent they are shared more easily. You have more likes or dislikes. But also you're looking at the type of the cascade of a tweet, its size, its lifetime, for how long it's persisting, how long it's active. So the whole, and in general, fake news or rumors, they tend to have, as I said, to evoke stronger emotions and more negative sentiments than compared to genuine news. Although this is, of course, to be debated because sometimes people have lots of very strong emotions to genuine news as well. But nevertheless, we were trying to detect misinformation here. So I'll just continue a bit about this type of work to find, because we're not, of course, several people have worked in this kind of relationship between emotions and misinformation. And this table reveals a bit the number of important relationships between emotions and information. So you see here, like COVID-19 related that we tackled before. It's also time lagged, and the angrier, sadder, and more fear the public feels, the more rumors there are likely to be. The first one, posts with a higher level of anger and sadness and anxiety are indicative of a rumor. There are several. Basically, we see that the premise that the misinformation is generally associated with a high degree of high arousal emotions, such as the ones that I described before. So those are several the data sets and EDs, emotion detection and sentiment analysis. And then the relationship, RAM is the relationship analysis method, and then the types of partly the relationship. And here I will talk slightly about the relationship between emotions and misinformation. Again, we follow the very well-known, because as I said before, there are different psychological models, which are both categorical, as Plutchik's here, and also dimensional. This type of Plutchik's wheel of emotion as well comprises here 8 basic emotions: anticipation, surprise, anger, fear, trust, distrust, etc. But also we have bipolar emotion pairs. So in Plutchik's wheel of emotion, these 8 basic emotions are organized to 4 pairs of bipolar. Bipolar is obviously the opposite petals, as you can see here in this figure. And these are anticipation, the opposite, and surprise, or anger and fear, trust and disgust, etc. So those are a type of organization of different types of wheels of emotion. Here on the different diagram, we look at what I mentioned before about the cascade size of these bipolar emotions. And basically on, the tweets that we can have anticipation or surprise or fear. So the cascade size or the cascade lifetime and the structural virality are also used to judge the impact of emotions and how a rumor can be spread. So as I said before, the cascade size corresponds to the number of forwardings. The cascade lifetime is to how long the length of time a rumor has been remained active. And the structure of virality provides a kind of aggregated metric combining the depth and the breadth of the cascade. So it's really here, this figure is, these three figures to show that rumors conveying anticipation or anger or trust, or which could be perhaps offensive, generate more shares, are longer lived and become more viral. So it's a kind of an indication why we should be focusing on emotions for misinformation detection. So the various types of features that have been used for misinformation, mostly is content-based. So but that's why I mentioned also before emotions and topics and domains and different features, because content-based information are the most diverse class as well. But also we have other types of information like dual information, which is like the publisher's emotions, the person who is posting something on social media, and the social emotion is how this, for instance, the emotions are expressed by people in response to a post. And again, I don't have the time to talk about, but there is we just did a review about this. Temporal information is important, different stance and sentiment, structure, the propagation structure, so use the number of followers. There are several types of features which actually support misinformation detection. For the content-based feature, I just highlighted some of these from linguistic informed or stylistic features, or clusters. So they're well-known types of features that we have been used. What are the challenges of misinformation and the direction? So first of all, like everywhere in our field, is the data set collection. So we have, typically we're using Twitter or Facebook or Reddit, and in different languages as well. So the challenges is that we have diverse languages and data formats. That actually causes problems about data processing. But the whole issue of misinformation is clearly a global issue. It's crucial to develop approaches that can be applied in a universal manner. So if we're talking about COVID, this was really a global problem. So we had to address multilinguality in different platforms. Unfortunately, most misinformation data sets are limited, and that's actually one of the problems. So they're either collected from a single platform, or typically they're consisting of very few languages. The most prevalent is English. There's also Chinese and Arabic, but mostly they're really the preeminent or Spanish, but prevalent languages, English and Chinese right now. So we need to have larger and more diverse data sets, basically encompassing all the problems that I mentioned before. Also, and now I'll start talking about LLMs, because the rest of my talk is going to be about LLMs. So obviously they're promising things, like compared to labor-intensive processes of manual annotation we had before, LLMs can annotate emotions and sentiments. It's a kind of very promising way. And also these models have a very kind of very promising way of transferability. Multimodality, I mentioned before, increasingly we have multimodal LLMs, augmenting a textual post with different images and videos. And interpretability, that it's important to understand the why misinformation, it's important how these decisions have been made about detecting misinformation. And the important part, we don't know if a post is indeed an article is deemed true or false. And this is very important for the transparency of our models. And as we all know, interpretability is a challenge with LLMs because despite the high performances, there's still a black box, not to mention they're actually generating hallucinated, they generate wrong text. So to sum it up about this, although of course creating models that they are both accurate and interpretable is a challenge, there are also several studies that propose very plausible solutions for explainable misinformation detection. There is quite a lot of potential in that area. Till now, the current misinformation detection methods, some of the most important are here. But here is some of the challenges that we have is that existing downstream data sets really lack emotion-related resources, such as emotion for misinformation, such as emotion and sentiment labels. So many of these misinformation or rumors, they use affective analysis tools like VADR or TextBlow2 or LYWC, etc. And also pre-trained language models, although they're extremely good have shown high performance in several classification tasks, and they have been applied to sentiment analysis and emotion detection. They're quite limited by the scale of model parameters in the training corpus. So we have a kind of lack of comprehensive understanding and the generalization ability for more sort of complex tasks, which I'll discuss, especially regression tasks. So LLMs, which are based on instruction tuning in sentiment analysis, mostly focus on single aspects of affective classification. So we have sentiment polarity or categorical emotions, similar to the ones I mentioned before, Klutzig's anger, fear, etc. But most of them, they overlook the regression tasks, and I think these are very important for detecting misinformation. So the strength of the emotion or the intensity of the sentiment strength or the intensity of an emotion. And these are perhaps the main reason of not great performance in several tasks. So, and the main reason for this is the lack of comprehensive affective instruction tuning data sets and different evaluation benchmarks, which actually cover the different various affective classification and regression tasks. So this is really the core what I said all that to focus on in this area. It's really how we can go about to detect and to incorporate intensity regression tasks into emotion detection for misinformation. So our first task, and this is the work of my PhD student, Jivei Liu, who developed, and other members of my team, we developed a series of emotional large LLMs for comprehensive affective analysis based on different dimensions, which I'll discuss immediately now. So there are now the two parts of the last part of my talk is about MOLLMs, the emotional large language models. And on the basis of the MOLLM, we developed the conspiracy theory detection using LLM, which is the CONSP MOLLM. And again, this was the reason we did that, is to tackle regression tasks for more fine-grained analysis. So the first one, the MLLM, is it's a suite of obviously open source LLMs, which are include an instruction tuning data set, an evaluation benchmark for multitask affective analysis. So the first thing that we all do when we build these things, we construct the multitask affective analysis instruction data set, AAID, which actually supports the LLM instruction tuning. This was based on Semeval 2019 Twitter effect, and included different tasks. These tasks are emotion intensity regression, ordinal classification of emotion intensity, sentimental strength regression, and sentiment classification, and multi-label emotion classification. Now, based on this instruction data set, then we build the emotional, or sometimes I call them emotional LLMs, which are, as I said, are open source. And then to evaluate the performance and how generalizable they are, we constructed an effective generalization testing instruction benchmark, the AB, which I will discuss now. So most probably all of you know about this, the Semeval. It's an old one, 2018 task. But in case this is, you didn't care much about effective analysis and regression tasks, this is basically the 5 types of emotions, like emotion intensity, which have been used actually for us to develop the different prompts. An example of that is if you have a tweet and an annotation of an emotion like anger, fear, joy, or sadness, then determine the intensity of the emotion that best represents the mental state of the poster. And then you have a real value between 0 and 1. But then you have the ordinal classification, which is really more interesting, because you have a low amount of intensity for one, or you can have a high amount of emotion. So those are quite interesting things to be able to do regression tasks. And then you have the valence and sentiment regression, ordinal classification of valence, and emotion classification. So based on that, those are the templates for constructing the prompts for the instruction data set. So you have, the task prompt, the tweet, and the emotion, and then the intensity, the score, which is basically adjusted to provide sentiment classification, strength, emotion classification, etc. So then on the basis of that, we have the MOLAMA. And here is an example of a prompt for the ordinal classification, emotion intensity. Categorize an example of the tweet into an intensity level of specified emotion, representing the mental state of the tweeter. 0, no emotion can be inferred, low emotion, and then you have the tweet. ICQ is just making me mad. Hashtag ICQ angry, obviously it's anger. And then, high emotion of anger can be inferred, etc. We all know how we're developing these things, but this is an example of a multitask instruction tuning of LLAMA with multiple affective analysis tasks. And now the last part, the next step of that is to evaluate the performance of MLLMs and to how they can be general. We constructed an effective generalization testing instruction benchmark, the AB, which contains, as you see here, about 14 affective analysis data sets, which have been collected from different platforms and sources. You have 8 regression tasks and about, I think, 6 classification from movie reviews to tweets and different data sets. And then here you have as well the task prompt, an example of the task prompts, examples for these data sets in our AAB, the instruction data benchmark. I'll just to wrap it up because of time as well, I'll give you some of the examples, the comparisons between the EMO LLM, the PLMs, pre-trained language models, with the zero-shot, few-shot methods. So if you look at, I don't know if you can see it, the small figure there, figure 2, between the comparison, you have EMO Llama, the leaderboard, GPT-4, ChatGPT, and Vicuna. So we see here the results. I have to say that the A and B, basically, we divided into 2 parts, but I don't have time to go through all that. So one we used, I'm giving you an example for the first part, which we used to test the training effectiveness of the models. And then we did another one for how general. So I'm just keeping the second one. So this figure here, the below, which is figure 2, tells us the results of the first part of A and B. And we're looking basically for MLLMs. We chose the EMO Llama Chat 13B, which has the best overall performance in comparison to other categories. And if you look also as well, assuming you can see it in table 5, you see that EMO Llama Chat 13B parameters B outperforms other LLMs and surpasses also the leaderboard, the top ranking. Now, for the complex tasks of emotion intensity regression and emotion intensity OC, EMO Llama again, Chat 13B shows high improvement compared to the leaderboard with the respective increases of about 3% and 6 for EMO Llama and 6.10 with EMO Llama again. So for other more independent raw task fine-tuning methods, we have the PLMs that you see here, BERT-based, Robert, and Centibert. Although these are trained on extensive data sets and fine-tuned separately for each task, the results don't surpass the original, the leaderboard. So in general, we can see here that general PLMs overlook important information compared to LLMs when dealing with affective regression tasks and fine-grained sentiment classification tasks. And then for zero shot and for a few shots, actually, I cannot hardly see the apologies myself, the tables here, with the magnifying glass. For zero shot and a few shot methods, we can see that the this category of methods in general performs poorly compared to other fine-tuning approaches, especially with emotion intensity regression and emotion intensity OC. So this basically, the overall is that LLMs without fine-tuning struggle to handle emotion intensity in an effective manner. We also compared between different LLMs, but again, we can observe from this table that MLLMs all perform quite well compared with LLMs without fine-tuning. So the story is, to sum up, is that proposed instruction tuning strategy for sentiment analysis outperforms PLMs and LLMs without fine tuning. And if we compare with other instruction tunes MLLM, the MOLAMA demonstrates is the most comprehensive and better capability in effective analysis. So as a sum up, there is more, but I think if you're interested, the paper is online. You can read it. To summarize for the MLLMs, it's still basically what we wanted to say is that there is still a kind of gap between the current open source LLMs and Chat GPT and GPT-4 in specific domains. One good solution, what we try to do is to demonstrate that an instruction tuning strategy such as the one I described before can improve, enhance the performance of LLMs in a specific domain and even surpass ChatGPT and GPT-4 in most tasks. And I explained the instruction data sets, the evaluation benchmarks, and and how it performs quite well in several analysis regression tasks. Okay, I'm doing okay for time, but I'll finish now with saying the last part, which is conspiracies. Now, the reason we developed MLLM is then to detect conspiracy theories, because we had a very small project in my lab. And again, most approaches to conspiracy theory detection normally, again, focus on binary classification, and they don't look at the relationship between misinformation and affective features. And then we started looking a bit more about the language of conspiracy. And the language of conspiracy, this is from different data sets like Loco and Coco that we have used, is that certain words and phrases that reflect psychological themes are associated with conspiracy theories. It's a type of misinformation conspiracy. Words like, between groups, again, we and them, or focus on languages on past events with absolute certainty, etc., etc. So there are various linguistic cues as well for understanding the language of conspiracy. So in this case, again, we developed the first, I think, open source LLM, you can correct me for that, for multitask conspiracy theory detection, which is based again on affective information. This is why I had to tell you all those things before. And for this, we used MOLAMA, hence we described them MOLAMA before. So what we did is we developed an instruction data set, which is called CONDID, to support this fine-tuning and evaluation. And this, we used two conspiracy theory data sets. One is Loco and Coco, which I'll say very briefly after. And then we used different tasks. CONDID has 5 tasks. So again, multitask, covering conspiracy theory judgment, theory detection, conspiracy theory intention detection, etc. And then we used also, we developed the conspiracy emotion NLM based on the CONDID data set. So those are the tasks, intention detection, if it's related, unrelated, or related but is not conspiracy. There is a lot on that on COVID. That's why I had to mention COVID before. A lot of conspiracy about that, but we also worked on other areas from a European project, which is about the Great Replacement, which is with the Center of Democracy and Trust in the University of Manchester. So there are lots of quite interesting, data sets that one can use to detect conspiracies. So the instruction data set CONDID is based on the 2 data sets which have been in the community. the COCO, and this COCO data set has labels with 12 different conspiratory theories like suppressed cures, behavior, etc., from New World Order, esoteric misinformation, etc., and local annotations that allows us to use differences between conspiracy languages and mainstream. So the data set statistics, again, perhaps don't have much time to show, but this is what you use to create different prompts. So we construct the instruction tuning data from each task based on the template task prompt, and the text mentions or refers to conspiracies. And those are the examples here of the task and the different types of prompt templates. But towards the end, we also, you have this, for instance, task determine the relatedness between the text and conspiracy, and classify it if it's closely related or broadly related. But to allow an evaluation of a bit of the impact of explicitly encouraging the LLMs to make use of affective information, which actually this is what we're interested in, is we also additionally constructed explicit prompts in the form that you see towards the end, affective prompt. So you can also refer to like emotion intensity, ordinal classification of emotion intensity, sentiment intensity. So these prompts, actually the last ones, provide information about the analysis results which we obtained from MOLAMA about the text to be classified. And this is a conspiracy MOLLM. Again, classify a text, and if it's like related and supporting, or what type of if a text is can you thank you God for perfectly making all injustice, harassment, etc. You say behavior control, anti-vaccination, etc. So this is the conspiracy MOLLM. And towards the end, to finish, you see some figures about the tweets, the emotion intensity of different intentions, the ordinal classification of emotion intensity, sentiment strength of different intentions, and sentiment classification, etc. So, we used MOLLM, but mostly we used MOLAMA Chat 7B for that, to conduct the sentiment analysis on COCO and local annotations around these 5 types of dimensions that you see: the intensity, ordinal classification, sentiment strength, sentiment classification. And then, well, a summary is, again, of course, this is ongoing work, that tweets which are related to conspiracy theories predominantly convey negative sentiments and emotions. And that's the 4 premises, how emotions are important. And then, sorry, somebody sent me a message, it's not for me. And then, in contrast, unrelated tweets are more likely to express positive sentiments and emotions like joy, love, and optimism. And also the types of emotions, you have that emotion classification in different intentions. I don't know if you can read it, like joy, disgust, etc. Also vary according to the specific category of conspiracy theory being discussed. So the last is really, we see now some of the results from the tables. We can see that for chat, for instance, GPT effect and conspiracy, LLM effect are the models that use the prompts containing explicit effective information, like words like sad, happy, etc. But from the results here, we can see that the fine-tune CONSP LLM and CONSP MOLLM outperform other open source models. so a kind of, we can basically see that using implicitly the use of emotion information by conspiracy MLLM is quite successful in allowing emotional cues to be leveraged. And also, if we're looking, I think, in the conspiracy, if you look at ChatGPT effect and conspiracy LLM effect, by explicitly augmenting the prompts with effect information, we have a reduced performance of all tasks, apart for task 4. So those things are still, quite interesting observations, but I think perhaps we can infer that by explicitly adding affective information might distract the model's attention to the task. And if you're using implicit use of emotion information, you might have basically a bit more successful. So that's it, and I'm wrapping up. We talked a lot about emotions and affective information, and we used it for developing emotional LLMs. And based on the emotional LLMs, we used the affective information for conspiracy detection based on conspiracy theories, and we used MLLM was fine-tuned using the multitask instruction data set, and it performs quite well among all other open source LLMs, but also ChatGPT in all tasks. So thank you, and some of the references of, the reference of what I've discussed today, this is the work of my team, my PhD students and ex-PhD students. Thank you.
Thank you, Sophia, for a wonderful talk. We will now take up questions from both in-person and virtual attendees. For the virtual attendees, please drop in your questions in the chat or the Q&A box. From the in-person attendees, do we have a question? Yes. Can you please come? Yeah.
Hi, Sophia. Really enjoyed your talk. Thank you. I was interested in the work you did in the first half of your talk about analysing or detecting emotion from tweets during COVID. And I was wondering, because I thought actually the level of negative tweets seemed quite low to me. So I was wondering if you had any comparisons that you could make to before the pandemic or to other countries or anything like that.
No, not with other countries. It's actually, I was very, this was the work of my Hassan Al-Husali's work. We're very surprised when we saw the type of optimism, because I thought it would be very negative. I mean, of course, they were negative, they're different, the variety, but overall, the tweets and the emotions, they were not negative. They're optimistic, maybe, perhaps, is the kind of anticipation and hope. This is something to be examined, but we really worked on about 50 cities in the UK, looking at the topics associated and the emotions. And as you say, it's very interesting to see, and I mean, there is, you can, if you read the paper, you see all the analysis, how we did that, and to see more in details. It is true, it's more positive. I would very much like to see more in detail with other countries, if it's a kind of, because the data exists, and it would be fantastic to do a kind of across different, how people perceived any different, not at the country level, but also at the city level. Yeah. As I said before, I think Leeds was the most, maybe the most pessimistic city. I cannot remember which one was the most optimistic, but there were kind of varieties. But indeed, this I think it would be very useful to see other types of contrastive comparative analysis.
Yeah, because I was thinking, because different countries had like different experiences in the pandemic and different policy decisions, so it might be interesting to link those to the emotions that you detected.
You're right. I mean, your observation is right. I thought it would be all gloom and doom, but it was not. in the tweets, or at least maybe we didn't select representative. Actually, we had 500,000 tweets, which was.
Thank you. Thanks.
Do we have another question? Yeah, we have another. Hi, Sophia. So I had one question related to the first part of your talk. So you were talking about using those emoticons in emotion analysis and all. So I was just wondering, because what happens is like some emoticons are like kind of, it is not ambiguous. People generally use it for certain kind of emotions, but for certain emoticons, it's like different people use it in different contexts. So I was just wondering, so was this the part of the model, or do you think it can be captured from the text?
In this type of the way we use, that's a very good question, because we did subsequent work on exactly on the topic you're mentioning, which has been accepted to CGIAR. So in this case, we didn't use it the way you said, but for a subsequent work on suicide detection, we're using emojis. We looked at different other contexts. So in this first work that we did 2 years ago, no. But it is indeed absolutely right what you said. So it's actually work that we're going to show, to discuss next month in CGIAR. But we use the emoji, but for emotions and emojis, and also for suicide detection. So yeah.
Okay, nice. And I had this another question. So you talked about this connection between emotions and misinformation, or like conspiracy. And you also concluded like, so mostly these negative emotions are related with this kind of conspiracy and misinformation. So I was just curious. So can you comment, like, is there any, have you observed any kind of particular negative emotions which is mostly correlated with this kind of things? Is that the case, or it is the case that if the negative emotions are beyond a certain intensity level, then always this likelihood increases of this misinformation or conspiracy?
The analysis, I mean, this is actually not our own. I mean, there's lots of discussions about this. Some people disagree with us and they say, you don't know if you have a negative emotion, that this is the misinformation. But it is the case that intensity and negative, and the analysis we have done, the intensity of emotions and the negative, if you cause fear or anxiety or sadness, actually sadness is considered quite neutral, there is most likely the tweets or the postings which are related with misinformation target that specific, because they're also, that's what I would talk about, the cascade. They are more prevalent, they live longer, they're more viral. So they're playing very much on the emotion, the negative emotion vitality, basically, of the post. So that was, so why were that was actually from the beginning why we were focusing on emotions and misinformation and conspiracies, especially. Because again, misinformation could be intentional, not intentional, but the conspiracies definitely are intentional.
Yeah.
I missed the second part of your question. Could you repeat it? So I don't want to talk. So you said something else about, so why we focused on the negatives, and something else you told me.
Yeah. So no, not why. I just wanted to know that what, like, one thing is like, what kind of negative emotions are most related with this kind of phenomena? That was one question. Or I'm like, whether it can be correlated or not, because that is itself a question, I guess, that whether it can be correlated or not. And if it is not correlated, then my question is it the case that, like, suppose I have 5 different kind of negative emotions, and we always see this kind of higher likelihood that if it goes beyond a certain intensity level, then only we see this kind of phenomena. So yeah, these are
That's actually, that's why we wanted, those are very interesting discussions, because we only observed by adding, for instance, the intensity, because most of them, they didn't have regression at all. It does make a difference. So if you have a very high intensity level,
intensity plays a role.
It's a kind of, because by just saying, anger doesn't mean anything. You can be angry, but you can be like neutrally or low angry. The intensity, that's why it was extremely important to put the intensity part into the emotions. negative emotions. And also by looking at misinformation, we saw the ones in conspiracy, the unrelated, they were mostly positive. And the ones which were more conspiratory and based on the data sets, they were the negative ones with high intensity. Clearly, I think this is an area that, I mean, more work should be done, and very happy to work with you guys if you're interested in this type of area. And also the emoji side. I think it's, for me, capturing the intensity and the regression tasks is very important for any kind of analysis. And still, we don't know. Some people disagree entirely with it. You don't know if it's true or not anyway. Well, that's why it's good. This is another discussion about the fact checking and also the truth of a statement or not. But most of them, they're just basically false or conspiratory.
Oh, okay. Thank you. Thanks for the interesting talk. Yeah.
Thank you.
We have another question from a virtual attendee. Just a moment. Explain a bit more about multitask instruction tuning. On the paper, it seems like the model is giving focus or attentions to some specific tasks.
Yeah, I mean, which paper? Because both are multitask. It's the conspiratory or the EMO.
She
They both
mentioned
multitask, and those are basically things that we used from the SEMEVAL data set, and they had different tasks. In both cases, we were focusing on the tasks from the existing data sets. So this was basically the basis that we created the prompts. And the only one for the conspiratory, we used also the affective part. But the multitasking was actually up from the tweet effect of SEMEVAL 18. So we were describing that in detail how we did. But this is also very important when we are doing this kind of MOLLM to use, to combine, basically to look at the different tasks that have been expressed. So if you're doing one part of analysis, you have only one facet of information. But for this, we just used the SEMEVAL 18.
Thank you. Thank you, Professor Sophia. Do we have any more questions? No. A lot of messages for you, people appreciating your work.
Thank you.
And yeah, expressing their admiration for you.
I should have come from Manchester to Liverpool, but anyway, quite a busy day. So thank you very much for having me.
Thank you, Sophia, for an amazing talk, and thank you for your support and time for this event. Really means a lot to us. Thank you.
Bye-bye.
Bye-bye. Thank you, Sophia. Thanks a lot.
Bye.
So, dear all, we will now have a concluding remark by Professor Danushka Bolegala, who is the head of the Natural Language Processing Group at the University of Liverpool. He will conclude this event by talking a bit about the event and about the Liverpool NLP group here in the institute, in the university. Over to you, Danushka. You can share your screen.
See my screen?
Yes, we can see your screen. Yeah.
So thank you everyone for attending this symposium we are having for the second time. And I think we had two great dates of lots of interesting, invited talks, as well as a lot of authors presenting their work related to social good, how NLP can be used for social good. And I have this task of presenting the concluding remarks and briefly introducing our group. So we are a relatively smaller NLP research group and consisting of 4 academics and the research associates and the postdocs associated with the academics in the group. So, but we do have researchers in very different fields. Prashita is looking into the information retrieval, fair and explainability in the models, which is quite important topic when it comes to using mainly like deep learned models, which are mostly like black box models, how to provide explainability for the decisions. So Tulika is working mostly on dialogue systems and their applications for social good. And Meng is working on the interactions between robotics and language interactions. On myself, so I've been recently looking into the ways of mitigating social biases that are identified in large language models. So we do have like people working in different topics, but we try to kind of mainly focus on top venues in NLP, such as ACL, EMNLP, and so on. So we have had lots of good successful papers in top venues, mainly led by our students. And our students like tend to, after graduating, they join academia or industry. There are lots of they've had a lot of success after graduating from the group. And we've also had lots of collaborations with outside research groups related to NLP. And we've had mainly a lot of people visiting us as visiting research students or visiting researchers. So if you're interested in like visiting the group and doing maybe a summer project or like spending few months during your PhD, last year of your PhD and so on, then feel free to get in touch. We might be able to help with this. So we've looked into various aspects of how NLP could be used for social good. And we've had successful research grants in this topic. So we looked into medical and clinical information extraction. And the Dinarix and Emmerich projects are mainly related to these applications. And from the legal side, we've worked with companies that provides legal services, and we try to use NLP for extracting information from legal documents. And NLP is a rather broad topic with lots of cross-disciplinary applications. And we've also borrowed some of the techniques from NLP and applied to solve problems in other domains. So one interesting problem we had is in defense, trying to identify activities related to smuggling and small boat activities. So we've modeled it as a topic model and applied models from NLP for topic extraction for these domains. And another like related like application is to apply transformer models for molecules. So molecules do contain atoms, which we can represent as either letters or words in a sentence. And then we can learn representations for small molecules as using the techniques that we have used successfully for building sentences or text representations in NLP. And another domain is cooking, where you have lots of recipes and try to find out what recipes could be useful for a given set of ingredients that you have. But this is a kind of interesting problem where we explored collaborations with a company called CookPad, which manages the largest cooking retrieval engine. And cooking is quite an interesting problem because the recipe is not necessarily a bag of words. So it matters the order in which you mix stuff in order to get the right dish. So we had to come up with order sensitive text representation. So there are lots of interesting applications of NLP in that we have explored, and we look forward to extend these collaborations in the future. In case of dialogue systems, for social good, so we've looked at various different fields, subfields like healthcare, education, and climate. So we've also had lots of interesting talks in this particular symposium related to these applications of NLP for social good. So we keep on working on this topic and try to produce more interesting work in the future. And one other important part of applying, when you apply NLP model for social good, is to provide explanations for your decisions. And this is quite important, especially in the medical domain, because you can't just make decisions and not explain why the decisions were made, for the reasons, to your patients or the practitioners. So providing interpretable, human interpretable explanations, quite important. For the medical domain, it's again the case for legal domain as well. So we've looked into our members in our group have looked into how to provide explanations for social good. And I'll briefly introduce one paper that I was involved in with the visitors, visiting research student Oba Daisuke from University of Tokyo, when he was a visitor at our Liverpool NLP group. So in this particular work, we were looking into how to mitigate biases, mainly social biases, gender biases in large language models. So as you know, large language models are trained on lots of text, and most of these texts are coming from the web, social media, and so on. So they do contain lots of diverse viewpoints, but some of these viewpoints could be quite disturbing, discriminative as well. So the language models tend to not just learn these biases, but also they tend to amplify these biases. So there have been lots of work previously trying to fine-tune the models such that these biases are removed from the models, which tends to be quite expensive. Fine-tuning can be expensive even when you try to consider large language models that have billions of parameters, even when you apply more parameter efficient fine-tuning methods. So another approach would be what we thought of, rather than mitigating, can you actually suppress those biases? You're using a language model that you don't have ways to fine-tune, but can you actually ensure that when you use the model, those biases don't surface and affect your users? So we call this bias suppression as opposed to bias mitigation, because we are not removing any biases from the model, but rather suppressing them. So we try to use instructions that we call the preambles here, that we would try to add to the text such that these biases will not be surfacing. So if you had a sentence, the woman was skilled in building PCs, and if the language model thinks women can't build PCs, it will assign a lower likelihood score. Let's say the probability tend to be 0.21. So that's a bias model. If it's assigning higher likelihood for the sentence, the man was skilled in building PCs, as opposed to the woman was skilled in building PCs. So by applying this preamble to the model, we tend to increase the probability. We are telling the model that females can also build PCs or become engineers, and we can also give some examples where this was the case. So we try to explore different ways of learning, creating these type of preambles and the effect of the models. So we have different ways of creating these preambles. We call them counterfactual preambles and descriptive preambles. So descriptive preambles will also describe, for example, the occupation of a particular person. And for example, the dental hygienist ensure oral health. So you just don't tell dental hygienist, some person is a dental hygienist, but also you describe what a dental hygienist's job is. So that way you provide more context for the language model to identify that this is a gender neutral profession. So by doing this, we find that you can effectively suppress gender biases in various large language models. And this is quite consistent across different models and the sizes of the models as well. So I don't know whether you can see the cursor. So the top, like NC means you without using any context. So that's the kind of default bias level. So the lower the value, the biases get reduced, mitigated. And the best kind of performance is retrieved reported by these counterfactual and detailed prompts. So this is a promising approach. You can increase the number of preambles that you are using in order to further reduce the biases. But again, it's not necessarily like the more prompts you use, you reduce the biases. You have to also have different ways to like criteria for selecting good prompts for this bias suppression. So we again in the paper we discuss various heuristics that you can use to identify better preambles for bias suppression. So one interesting aspect of using bias suppression through this type of in-context learning setting rather than fine-tuning models is that when you tend to fine-tune models to address things like gender bias, so there is a tendency that is reported in much prior work that the performance of the LLMs reduces because you are trying to remove information related to gender. So ideally, you want to remove only the stereotypical information related to gender, but because of the way these fine-tuning data sets are created, then there's no way of like identifying which information related to gender is stereotypical, which should be left alone. So it tend to like remove too much information related to gender from language models, which tend to be like reducing performance in the models. Because gender is also an important aspect when making various like predictions in text. So one good thing about using these type of preambles is that the reduction of performance due to bias suppression is rather minimal compared to like fine-tuning type of approaches. So you can suppress biases at the same time not having drastic reductions in the accuracies of the models. So this is an advantage of this approach. So we have the models and the data sets publicly available. You can give it a try if you're interested. So finally, to conclude today's 2 days workshop. So we had a lot of interesting talks, but this would not be possible if it was not for the hard work of Tulik and Prashita for put into organizing this workshop. So I think they do deserve a round of applause for their hard work. And this was again possible for the second time because of the funding and the support from the School of Electronics Engineering and Computer Science. And I would like to thank all the invited speakers as well as the authors who submitted their papers and then presented their work in the symposium yesterday and today. And hopefully we will be able to do a third edition of this. So stay tuned for that. And with that, I would like to conclude the symposium. Thank you very much.
Thank you, Danushka, for your talk. We will now take up if there are any questions from the in-person or virtual attendees. The recorded video will be available through the symposium's YouTube channel, if that's your question. I think we don't have any questions. So thank you everyone for joining us. We will conclude the event. Hope you enjoyed NSG 2024. We will see you again next year. But before leaving, we want all the virtual attendees to please switch on their cameras. We are going to click one picture as a memory. Yeah. Thank you. Please, if all the virtual attendees can please switch on their cameras. Yeah. Please hold on, everyone. Thank you all for joining. We'll conclude the event. Thank you. See you all next year. Thanks.
Bye.
Yeah.